Hello, everyone. Welcome to today's session on the human eye and the colorful world. So, in this chapter, let's look at the other concept, that is dispersion. What is dispersion? So, Sir Isaac Newton, the the great physician, right? So, what he has done is he has conducted one experiment. In that experiment, what he has seen is he has passed a sharp beam of sunlight, so through a cardboard, right? So he has made a cardboard and made a hole, and he put that in front of sunlight so that a small sharp beam of light passed into the through that small hole. So then what he has observed is when that light is refracted through the glass prism, what he has observed is he has observed an image, right? The image, the light ray, the emergence ray, if he kept a screen, he saw that there are different colors of a band, that's a spectrum, is being formed. So what is dispersion is basically, dispersion is the splitting of white light. So white light is the sunlight, right? The natural light. So the natural light has colors that we don't see with our naked eye. So how we can see is when this white light undergoes refraction through a glass prism, what happens is when it enters, when the white light enters here at the interface, right? If I draw the normal here, what happens is the light undergoes deviation, right? The light refracts and bends towards the normal. So as we have 7 colors, right? 7 colors in the light, that is WIBGR, WIBGR. So we can look at what those colors are later. So they forms a different WIBG, WIBGR. Yeah, Y is missing here, guys. Okay, WIBGR. So 7 colors. So what happens is each color light has different wavelengths. That means different speeds. So when we have different wavelengths, when it refracts through the prism, what happens is, as at the first interface AB, it refracts, and the violet light, which has low wavelength, that deviates more compared to blue light, compared to indigo, compared to blue, compared to green, like red and orange, which has less, which has a greater wavelength, that bends less. So what Newton has observed is, so there is a dispersion of light is happening. So the white light, a single beam, is spread into a different colors at the first refraction. And then again, what is happening at the surface AC, that's that dispersed light will get further dispersed, because it is undergoing deviation again. It is undergoing refraction again from the glass into the air. That's where he kept a screen somewhere here, right? To capture like what is that light is. So when that screen is kept here, he has observed a different 7 colors of image that is formed on the screen, on the white screen. So that's how uh, our great physician Newton has concluded that the white beam of light, the sunlight, or the natural light, is a combination of 7 colors. It's a 7 colors, that is WIBGR, that is violet, indigo, blue, green, yellow, orange, and red. So what is dispersion? That phenomenon, that process of the white light dividing into 7 colors, different colors, is called dispersion. So if you want to write the definition, dispersion is the splitting of white light into 7 constituent colors when it passes through a transparent medium like a glass prism. Okay, so that's the dispersion of light. So what are those colors, guys? It's WIPGR. And then why does dispersion happen, right? So why dispersion happen? So white light is a combination of different colors. We cannot see with the naked eye, but when dispersion happens, we can observe that. So there is one example. We can cover it later. So when white light enters a prism, it bends at different angles at the first interface, and then it refracts further, disperses further when it goes through the second surface, that is AC. So when white light enters a prism, it bends at different angles. Violet bends most because it has a shorter wavelength, and red bends least because it has a longest wavelength. Okay, this you remember, guys. So as a result, the light spreads out into a spectrum. So what is the spectrum? The white light dispersed into that 7 colors, right? So that band of colors that's captured on the screen is called the spectrum. Understood, guys? So dispersion is splitting of the white light into 7 constituent colors when we pass it through the glass prism. Okay, so what are those colors? WIPGR: violet, indigo, blue, green, yellow, orange, and red. So violet deviates the most and red deviates less. Okay, because of their wavelengths. Then, so this dispersion, right? What is an example of dispersion in our real life? It's a rainbow. So I think most of you would have seen the rainbows, right? During the rainy and sunny atmosphere. So a rainbow is basically a spectrum, right? Splitting of the light into that 7 bands. So if you observe the uh, rainbow closely, this is basically the WIPGR colors, right? So you'll have 7 colors, the predominant colors we will see, but there are 7 colors in that. So a rainbow is a natural spectrum of sunlight that appears in the sky after a rain shower, right? So when we have a rain shower, what we will see, this rainbow we will see, it is caused by one, dispersion, splitting of the light, and refraction, because the light undergoes refraction. Where it undergoes, what medium change here is happening when the light ray enters into the water droplets. The rain is water droplets, right? So when the light enters the water droplets, it splits into it disperses into the spectrum, and that reflects and then comes out. So when we see that, so if you see in the bottom diagram here, the sunlight is entering into this raindrop, and here at the first surface, what is happening is it is dispersing into that WIPGR colors. And when it hits the other surface of the water droplet, it is completely reflecting back. And here, from water into air, it is coming out. So again, what is happening? It is further dispersing. So this phenomenon, when we see from the distance, right, the splitting, the dispersion of light through each water, each raindrop constitutes a rainbow, right? So if you want to exactly say, a rainbow is a natural spectrum of sunlight that appears in the sky after a rain shower caused by dispersion, diffraction, and reflection, right? So here it is dispersion. This is dispersion. And here, this is also dispersion, right? At this surface, it is further dispersed. Then what is happening at this surface? At this surface, it is refraction. And then what is happening at this surface? This is internal reflection. So rainbow is a combination of refraction, dispersion, and internal reflection of the sunlight in the raindrops or water droplets. Now, how this is formed, right? So sunlight enters a raindrop in atmosphere. So it refracts and splits into 7 colors at the first incidence. Then The light gets internally reflected on the internal surface, that is internal reflection. And then that light exits the raindrop and there it is further dispersed. Okay, so these rays reach to the observer's eye at slightly different angles, showing the spectrum of colors. Okay, now what are the conditions for seeing a rainbow? So when we will see, we have a rainy season almost 3 to 4 months in a year, but we won't see every time it rains, right? So in which scenario that we can observe rainbow? So the scenario is the sunlight must be behind the observer. So the sun must be behind us. That's number one criteria. And the raindrops must be in front in the opposite direction to the sun. So that means if rain is on the east side, the sun should be on the west side. We are in the middle, right? So for us, to the back we have sun. To the front, it's raining. Then it is common after a rain shower or maybe near waterfalls. So if we go near the waterfalls, that water droplets, that the fog kind of thing that goes into uh, the air, when when sun rays hits that, it forms like a WebGR. That's the rainbow. That's the spectrum of the colors. You can see that. So when we have both sun and raindrops, what we can see, we can observe the rainbow. And also, why we will see rainbow in the semicircle shape, right? So the semicircle shape we are seeing because we are observing on the Earth's horizon, right? So the observer is here and we are observing like this. So if you go to the top of a mountain or something, we may see this is a full circle, right? It depends on from where you are seeing it. Because if we see we are on the Earth's surface, if we see to the front, so we will see only half of it or a portion of the spherical, right? So if we are on the top and observe, right, then we can see it's a full circle rainbow. So rainbow is a typical example of spectrum. So that's how we can say the white light has 7 different colors, and we can see that through using dispersion. When using a prism, when we pass the white light through a prism, we can observe that this is dispersed into 7 colors, and those 7 colors, if we capture onto a screen, that is a spectrum. Okay. All right, guys. So that's all, guys. I think hope you understood the topic. And in case you have any questions, you can connect me using Urban Pro Profile.